This is the mock exam for chi-squared GOF, and t-test. First problem, a university required all science students to study one language for 1 year. Survey was carried out at the university amongst the 150 science students. These students all studied French, Spanish, or Russian. The results of the survey are shown below. Okay, so I guess the grand total for this is 150 students, but they didn't give us the subtotals. I'm just going to add them up real quick because we know that in any kind of chi-squared problem we need to know the totals. So 9 plus 31 is 40. 29 plus 49 is 69. And 12 plus 29 is like 41, I think. Okay, and let's just make sure that those add up to 150. 40 plus 41 is 81. 81 plus 60 is 141 plus 9 is 150. Yeah, that adds up. And then if I want to add the females together, it's 29 plus 9 plus 12. That would be 50, right? I'm sorry, 51? 51? Yeah, 51. And then 31 plus 40 is 71. 71 plus 29 is, I'm sorry, it is 50. 31 plus 40 is 71. 71 plus 29 is 100. Okay, so those are the subtotals and the totals. We'll need those later. Ludmila decided to use the chi-squared test at the 5% level of significance to study the choices below. Remember, 5%, we convert that to 0.05 because later we're going to compare that to the p-value, okay? State Ludmila's null hypothesis. Remember that the null hypothesis is always blank and blank are independent. So in this case, what are the two categories? There is gender and there is language. So gender and language chosen are independent. Okay, so what is the alternative hypothesis? The alternative hypothesis would just be the opposite of that. So gender and language are not independent. Okay, and remember that this is the format for a null hypothesis only for traditional chi-squared. It's different for the other tests we're going to do on page 2 and 3. Write down the number of degrees of freedom and show how it was calculated. So remember that it's a 2 by 3 matrix, so the way you calculate degrees of freedom for a 2 by 3 matrix is you subtract 1 from the number of rows, you subtract 1 from the number of columns, and that gives you 1 times 2, which is equal to 2. Show how the expected frequency for the female studying Spanish is calculated and calculate the answer. Okay, well, first of all, female studying Spanish is this number here, but actually the expected frequency has nothing to do with 29, which is the observed frequency. 29 is what actually happened. What we're going to do is we're going to figure out using the subtotals and the total what would be there if the world had no favoritism, bias, everybody wins a trophy, okay? What we would do is we would take the two subtotals, 50 and 69, we would put them over the grand total, 150, multiply them together, and then finally multiply by 150. So first we would do 50 divided by 150. We would multiply that times 69 divided by 150, and then we would multiply that times 150. So that what we did was we used the subtotal corresponding to Spanish, the subtotal corresponding to female because they said female studying Spanish, and we just divided by the grand total and multiplied by the grand total, and that gives us the proportional value that we would expect to see instead of 29. So let's see what that is using the calculator. So be faithful to the parentheses. Let me show you how to use the calculator so that you don't have to use parentheses as much. So if I inserted these as vertical fractions, then I wouldn't need to put the parentheses there. So let me show you how to do that. So you do math, and then I go to number, and then I go to the very bottom, and it has n/d, and this allows me to input a vertical fraction. So I'm going to do that. 50 divided by 150. And then I'm going to multiply that times another vertical fraction, which would be do math again. Number n divided by d, and I'm going to put 69 divided by 150. 69 divided. Isn't that cool? And then the last of all, I'm going to multiply it times 150. Then I don't need to put parentheses around everything. 23 is the answer. So the expected frequency of females studying Spanish was 23. We got 29, a little bit different. Is that different enough to say that they're not independent? We'll see. Use your graphical display calculator to find the chi-squared test statistic for this data. Okay, so what we're going to do for this is we're going to do second matrix because we're putting in a table. The only way we can put in a table is with second matrix. We're going to go to Edit, and we're going to put this data that we see here in the A matrix. So we'll click on A, and this is a 2 by 3 matrix, so we're going to put 2, 3, and it'll automatically make a 2 by 3 matrix full of zeros. And then we're just going to put in the numbers here. We use Enter and arrow keys to maneuver about the table as you put all the tables in, as you put all the data in. And after you do this, the calculator calculates all the expected frequencies on its own. It puts the expected frequencies into the B matrix when we execute stat test chi-squared. Okay, let's check my numbers, 931, 2940, and 1229. Now what we're going to do is we're going to do stat tests, and then we're going to go to the bottom, and there's chi-squared, which is option C. And then it says the observed matrix is A. Yeah, that's where we put the observed data, so that's fine. The expected matrix is B. The calculator is going to fill that in. Color doesn't matter. And then we go down to calculate. Oops. Darn it, I hit the wrong thing. Stat, darn it, this emulator calculator is such a pain. Oops. Now I'm really screwing up. Stat test. And then we're going to go to option C because that's traditional chi-squared. Enter. And then A, B, and we go down to calculate. Now I'm going to be very careful to hit enter and not the plus sign. Okay, so my chi-squared value is 4.77 if I round to the nearest 3 significant figures. So my chi-squared statistic is 4.77. And let's see, if they asked me for the p-value, the p-value would be 0.0923. And then I'm going to look at the next step, which is it tells me that the critical value is 5.99. I'm going to compare which one to 5.99? Remember, the chi-squared value is compared to the critical value, okay? So we are going to take chi-squared and we're going to say, is it greater or smaller than the critical value, okay? So the chi-squared value is 4.77, and that is less than the critical value of 5.99, and if it's less than, then we accept the null hypothesis, okay? All right, and the next part says justify your conclusion above using the p-value. Okay, so p-value, remember, the p-value we compared to the significance level. The p-value is 0.0923. We're going to compare it to the significance level of 0.05. We already converted it to a decimal. And it is greater than the p-value. Since it is greater than the p-value, we will accept the null hypothesis. We'll get the same result either way, okay? Now you can see that if the significance level is 10% in this case, we would be smaller than the significance level, and then we would reject the null hypothesis, right? If we accept the null hypothesis, that means that there isn't a relationship between gender and language is chosen. Okay? There's no bias. All right. Number 2. This is another chi-squared problem, but this is going to be the goodness of fit test. Okay, so Brazilian holidays fall on each day of the week in a uniform distribution. Alexandre decides to study whether the data for the last 5 years satisfies a uniform distribution using the chi-squared goodness of fit test at a 1% significance level. So we're going to look at the data that we have here. Is this a table? No, it's not a table. It's a list. So we're going to put this in a list eventually. Let's see what they ask us first. Part A, state Alexandre's null hypothesis and alternative hypothesis. Now remember, the null hypothesis for the first page was blah, 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 and blah, blah, blah are independent. In this particular case, it's goodness of fit. What we're looking for is Brazilian holidays are uniformly distributed. So that is the null hypothesis for goodness of fit test. Okay? So what's the alternative hypothesis? The alternative hypothesis is always not blah, blah, blah. So it would be Brazilian holidays are not uniformly distributed. Okay? Write down the number of degrees of freedom. Okay, degrees of freedom for goodness of fit test, also known as GOF, is the number of boxes in your table minus 1. And there are 5 boxes here because there's 5 weekdays. So it'd be 5 minus 1 equals 4. Write down the table of expected values. So for this one here, we're going to make a similar table to the one we have above with 5 boxes. And we're going to put Monday, Tuesday, Wednesday, Thursday, Friday across the top. And we'll put expected frequency here. And what we're going to do is we're just going to figure out if there was no bias, then we would expect to see the same number of holidays every day of the week. So what we're going to do is we're going to add all these up and see the total, and then we're going to divide the total among the 5 days evenly. So this would be 62, 83, it'd be 100. So there's 100 total. So we're going to take the total of 100, we're going to divide it by 5, which gives us 20, and we're going to put 20 holidays on each one of the days. And that's what we would expect to see if all things, if there was no bias between days of the week and which holidays they fall on. Determine the results of the goodness of fit test at 1% significance level. Remember, 1% significance level corresponds to 0.01, so we're going to compare our p-value to 0.01. Whether the observed data fits a uniform distribution. So now what we're going to do is we're going to input the data in the calculator. Since it's a list, we need to use stat edit list instead of second matrix. And in the first list, we're going to put our data. In the second list, we're going to put our table of expected values. So here we're going to put 28, 22, 22, 22, come on 2, come on 2, okay, 12, 21, 17. Okay, and then the next column we're going to put the expected values, which are 20, 20, 20, 20, 20, 20, 20, 20, 20. Check my data, see if I put it in okay. Okay, then I'm going to do stat, test, go to the bottom, GOF, which is option D. List 1, list 2, if I never stray from using list 1 and list 2 as I did with the observed in the first and the expected frequencies in the second, then I can just leave it as is. Now for DF, I'm going to have to put in 5 minus 1 equals 4. So I put 4 there. And then I go down to calculate. And my chi-squared value is, I'm just going to write that down even if they don't ask it. I don't know if they're going to ask me, but Chi-squared is 7.1, and the p-value is 0.131. Okay, degrees of freedom is 4, of course. I put that in. Determine the results of the goodness of fit test at 1% significance level to find out whether the observed data fits the uniform distribution. Okay, the p-value is 0.131. I'm going to compare that to the significance level. It is bigger, which means I accept the null hypothesis. Okay. Then it says critical value is 13.28. State Alexander's conclusion for the test. So the critical value is compared to the chi-squared statistic, and it is less than, which means we accept the null hypothesis. Same result as before, right? Give a reason for your answer. Just did. Give a reason for your answer considering p-value. Oh, I already did it there. Okay? Easy, right? Accepting the null hypothesis means even though the distribution wasn't exactly 20-20-20-20-20, it's close enough for us to say, yeah, there's nothing weird going on here. There's no conspiracy putting Brazilian holidays on Wednesday so that we don't do Ponte. Okay. Last problem. Okay, third and last problem. We are going to talk now about t-test. The 2026 Math HL cohort believes that they are academically superior to the 2025 cohort. Mr. Tsubaki wants to compare the first semester math grades from the two cohorts to check if they are. Here are their grades. So the 2025 cohort has 6 students, so there's 6 grades. The 2026 cohort has 8 students, so it has 8 grades. At the 10% significance level, a t-test was used to compare the means of the two groups. The data is assumed to be normally distributed and the standard deviations are equal between the two groups, okay? When we say we use the t-test to compare the means, we're not just comparing the means. The means are just two numbers. We're not just comparing the numbers. What we're doing is we're comparing all the numbers which are used to calculate the mean. Look at how spread apart they are. Look at the actual values of the mean. See how different they are. The t-test does all this for us, okay? The null hypothesis for the t-test is always that the mean for group 1 and the mean for group 2 are equal. So I'm going to put here that the null hypothesis is that the group 1 mean, or the 2025 cohort mean, is equal to the 2026 mean. And you might say, oh, but doesn't it say that the 2026 cohort believes they are superior, so theirs is greater than the 2025? That is the alternative hypothesis. So the alternative hypothesis is that the 2025 cohort mean is less than the 2026 mean, right? And you might say, well, why didn't I put 2026 is greater than 2025? Well, because 2025 comes first, so this is group 1 and this is group 2. It's more convenient if we think about always listing group 1 first. So on the calculator, the way you're going to see this is we're going to see mu1 is less than mu2 because its group 1 mean is less than the group 2 mean. The 2026 cohort is group 2. It's greater than group 1. Okay, and then this one is mu1 is equal to mu2. Calculate the p-value for the test. So to do this, we are going to use the calculator. So we go in here, we do stat edit because we're going to input these two lists in here. When inputting lists, we're going to do stat edit. Like we said, there are 6 students in the first group and there's 8 students in the second group. It doesn't matter that each group has a different number of students. That's one of the great things about t-test. It takes that into account for you. 76, 83, 74. I'm going to stop the camera and then I'm going to continue. Okay, the data is in list 1 and list 2. Now I'm going to do stat test, t-test, and the t-test option we use is 2 sample t-test, which is option 4, not option 2. And we leave input as data because we're going to put in data. Our lists are L1 and L2. Frequencies we leave as 1. Now this is the alternative hypothesis. The alternative hypothesis, in this particular case, we would like it to be mu1 is less than mu2. So mu1 is less than mu2, enter. Pooled, we should always put yes. Okay, only maybe on the IA will you put something different, and then calculate. So it gives us our alternative hypothesis, mu1 is less than mu2. The t-value, I'm going to write it down even though it doesn't ask us for it. So I'll put t-value is equal to negative 0.101. The p-value is equal to 0.460. And state giving a reason whether Mr. Tsubaki should accept the null hypothesis. So I'm going to use the p-value to determine whether I should accept it or not. Of course, I'm going to compare it to the significance level because the p-value is always compared to the significance level. The significance level here is 0.10. I always need to convert it to decimal. 0.460 is greater than 0.10, which means that we accept the null hypothesis. Okay? If we accept the null hypothesis, that means that the two are equal to each other, so the 2026 cohort is not statistically greater than the 2025 in terms of their grades. That's it. Oh, just wanted to add a couple more notes. When is it that you would choose an option that is not mu1 less than mu2? Well, let's say that instead of the 2026 cohort believing that they are academically superior than the 2025 cohort, what if they said something like, we believe that we are different than the 2025 cohort? Maybe we're better, maybe we're worse, but we're not the same. So in that case, what you would do is you would do stat test, and you would choose, we want to choose option 4, and you would choose the not equal to option. So then the alternative hypothesis that the 2026 cohort is not equal to the 2025 cohort. Another question that they might ask you on the exam, which is not asked here, is if it's one-tailed or two-tailed. Okay, a one-tailed test or a two-tailed test. Basically, if it's mu1 is less than mu2, or it's mu1 is greater than mu2, then it's a one-tailed test. And if it's mu1 is not equal to mu2, then it's a two-tailed test. One way to remember that is when it's not equal to, it could be less than or greater than. So they're looking at the left and the right side of the distribution. So it's kind of like you're looking at both tails, the left tail and the right tail. When you have less than only, or you have greater than only, then it's a one-tailed test. Okay, now I'm really done.